G'day team, it's Mr. Collins with another A grade video. Today we're looking at covering exercise 13G, which focuses on drawing logarithms. So as we discussed in our previous class, logarithms are in essence just an inverse of exponentials. So just to show how that works, we're going to revise a bit from our previous topic on functions to show that this is actually an inverse. So step one of finding an inverse is flip x and y. So then x would be from here, x would be equal to 10 to the power of y. 2 is make y the subject. So to make y the subject, we'd need to take, just like we solved, take log to the base 10 of both sides. Log base 10 of x is equal to log to the base 10 of 10 to the y. So therefore y, pulling that out the front using our log laws, y would be equal to log to the base 10x. So y equals log base 10x is the inverse of y equals 10 to the x. So if we were to graph that, and this is in your textbook on page 457 as well, graphing inverses without even looking at the properties, if y equals 10 to the x is just a standard exponential, so it will look like roughly like that, with that intercept at 1. That's going to cut across a mirror image across this 45-degree angle, y equals x. This is y equals 10 to the x. Going to have a mirror image for, roughly mirror image anyway, y equals log 10 to the x. Okay, so inverses always reflect about this 45-degree angle axis. So when we're graphing a logarithm, key properties is the domain is all, that's actually not real x, that's all real positive, really important, positive x. Or the other way to write that is r plus. So x cannot be 0 or negative, as you cannot raise 10 to any power to get negative or 0. So remember, if y is equal to log the base 10 of x, that's the same as saying 10 raised to the power of y is equal to x. Okay, so raising anything to the power of y, no matter what y is really negative, that's just going to create a big fraction. And if y is very positive, that's going to create a very large number. So you can't raise 10 to any power that's going to give x equal to 0 or negative numbers. Okay, so that kind of creates our asymptote at y equals 0. Just like with our exponentials, we had the asymptote at x equals 0. So because it's an inverse, it swaps where the asymptote is. Another thing that we need to note is x-intercept. So sorry, this is a bit messy, guys. Put it in your books a bit neater. X-int when y equals 0, so when 0 is equal to log to the base 10 of x. So therefore 10 raised to the power of 0 is equal to x. X equals 1. So our intercept, just like I've indicated there, is at x equals 1. So just like when we're looking at exponentials, we're focused on finding the asymptote, the horizontal asymptote. Here, we're looking for the vertical asymptote. So we're focusing on our domain rather than our range as we were with exponentials. So exponentials is about range, logarithms are about domain as they're inverses, so it flips. So let's look at a couple of different translations. So your standard graph you need to know is this one up here. And this is a couple of translations that we can look at. So same process as always. Draw our graph first. We've got, looks like there's going to be a translation here. So we know that x plus 1, just like with our standard graph, x could not be equal, or less, x could not be, basically x had to be, sorry, that was x equals, asymptote is x equals 0, not y equals 0, my bad. X has to be greater than 0. Here, x plus 1 has to be greater than 0, because 2 cannot be raised to any power that's going to give 0 or a negative 1. So therefore, x has to be greater than negative 1. So straight away, we'd use a rule for this. Neg 1 is our asymptote. And then x-intercept when y equals 0. So when 0 is equal to log to the base 2 of x plus 1. So therefore 2 raised to the power of 0 equals x plus 1. 1 equals x plus 1. Sorry, I just need to shift down. 1 equals x plus 1, so x equals 0. So y-intercept when y equals 0 is at x equals 0. So straight away, we don't need to calculate the other, the y-intercept, because we've already found it, because it's at 0, 0. Okay? So that was a bit of a shorter one. Y equals log 2x. It'd be great if you guys would have a pause now and have a go at trying to figure out, by finding the asymptotes and the intercepts, what our coordinates would, what our graph would look like here. All right, we'll go through it now. So first off, asymptote, just like above, the subject of the log, 2x must be greater than 0. Divide both sides by 2, x must be greater than 0. So that's our asymptote there. X in when y equals 0. So when 0 equals log to the base 2 of 2x. So 2 raised to the 0 is equal to 2x. 1, 2 raised to 0 is 1. It's equal to 2x. So therefore x is equal to a half. Okay, so that's actually shifted the asymptote. So it's increasing. So it's increasing quite swiftly there, and then it plateaus as it goes more. So increasing at a decreasing rate for you there, cool. All right, so that was that one. Last one will be, once again, pause your video, try and have a go. Just play around with it, guys. Looking at trying to graph this one, trying to find your intercepts, your asymptotes, and then I'll get into it. All right, so looking at this one, you always graph your plane first. So you got y, you got x. Now, this one might appear that because you're shifting, you got a 1 plus log 2x here, that your domain might change. But your domain, remember, you're still focused here. X must be greater than 0. Because it's part of the log here, you're just focusing on the x here. X cannot be a negative number, and it cannot equal 0. Because once again, 2 raised to any power cannot equal 0. So your asymptote is once again your y-axis, so you're not going to have a y-intercept. So then you just need to find your x in when y equals 0. So 0 equals 1 plus log to the base 2x. If you were struggling before, maybe pause now, have a go at rearranging this, see if you get it. Then you'd take in 1 to the other side, y equals log 2x, negative 1 equals log 2x, sorry. So 2 raised to the negative 1 equals x. So once again, just using that method of it turning a log into an exponential. So 2 to the negative 1 is the same as 1 over 2. So intercept is at a half as well. So it's going to look quite similar. probably less steep there though when you compare this one to the log base 2 of 2x. Okay. So once again, you could have other different translations and you'll come across them in the exercise, but just have a crack, see how you go, and then we'll ask questions on Teams and in class. Good stuff, guys.